Thank you.
Thank you very much.
Thanks, and our last in the herp section here, we have Rob Fisher talking about Cryptoblepharus. Come on.
If you need a pointer, it's the bottom, and use left and right.
Okay.
Something else you wanted to pull up?
No, later.
No,
I got
that's
that later.
Hey, you guys can hear me okay? So I'm gonna talk about another species. I mean, this is great following both John and Eric. I think they talked about the harder stuff, and mine will be a little easier. I'm gonna talk about Cryptoblepharus, called the snake-eyed skink, and I'm gonna give some background about it and show how we're thinking about it in the U.S. Pacific. And sorry. So here's my talk. I'm going to review how we determine if a species is endemic, native, or invasive. We just saw from Eric how he categorized species into these different categories. So I'll talk about that as well and some of the evidence for it. I'm going to review the origin of the genus Cryptoblepharus. I'll review the Cryptoblepharus distribution in the Pacific. There's a computer right here. I'm going to talk about the genomic analysis sorry, like that? Is that okay? Recent genomic analysis we've done, and then what does our analysis, our recent genetics work, like what John showed, but for Cryptoblepharus, what does that tell us about diversity within the genus in the Pacific Basin, and then the current status of Cryptoblepharus within other U.S. Parts of the Pacific. What are some of the risk factors affecting Cryptoblepharus? And then I'm going to talk about this Christmas Island example that, like John alluded to, for the extinctions that have been going on there, and what can we learn from that, and next steps. So I'm going to talk for like 2 hours, I think. So how we determine if a species is endemic, native, or invasive. So for the tropical oceanic Pacific, we have kind of two concepts. One is long-distance dispersal, which John talked about, where we can determine by fossils, genetics, morphology, geographic distribution, whether or not a species has a longer history in the region. And then that should exceed typically about 4,000 years in a lot of the tropical Pacific. The other is this human-mediated dispersal, and then we can determine using the same techniques as a long-distance dispersal, and they can generally be divided into 3 periods when a species might have arrived into a place. Pre-European contact, which is usually greater than 500 years, dispersal via whaling, manila galleons, early exploring expeditions, often had poor biosecurity and introduced species, and then dispersal via increased trade and wars like World War II greatly increased the numbers of species that we showed showing up on islands. And so by determining the mechanism, we can identify which species become priorities for conservation. So for example, the long-distance dispersal species are the ones that might be the ones we really want to focus our conservation actions on and pay a lot less attention to species that dispersed real recently. So Eric had that great slide that showed the most abundant species in Saipan were the ones that are the least important for conservation. The ones like Poecilopleurus and Cryptoblepharus might be the most important species. And I'm going to focus on Cryptoblepharus that he showed might be one of the most important species on that island for conservation. So I'm going to just give 3 examples of these different dispersal events and how we kind of filter through them. So this is an example from my thesis work. This clock here isn't right? It's like, I haven't even talked for 4 minutes already, right? Shut up. So for Gahyra oceanica, this was all one species. Now, through using genetics and some morphology, it really is probably 6 different species in the Pacific. And then what we've seen is also we see this blue in the bottom, and this little bit of green here is evidence of a human-mediated dispersal. We're pretty confident from fossils that the Marianas distribution is actually an artifact of human-mediated dispersal, even though it's an endemic to Micronesia. For Amoya cyanura, sampled Guam, Cocos Island back in the 90s, and it's identical to Kosrae. and a lot of like Hawaii and other areas are identical to each other. And for Moya cyanura, we have good evidence from genetics that there's been human-mediated dispersal across the Pacific, and including to Guam. And even though it's a really rare species in the Marianas, it's probably not important for conservation. When we look at Lepinia noctua, which is a rare species in the Marianas, we have it's been untested for long-distance dispersal or human-mediated dispersal. There's a previous paper that looked at genetics in the Pacific Basin for Lepinia noctua, and what it found was that across the South Pacific, this is all human-mediated dispersal, but that within Micronesia, there's some structure, and Marianas is untested. And so it could be, this is definitely an endemic species, and this will retain the name noctua. This is an undescribed species that's been human-mediated, but we don't know what's going on with Marianas. Also untested are Amoya strilicata, Parachirus, and Varanus, as far as whether or not they're native and important. I know everybody talks about Varanus being introduced. I'm not sure until we test it that that's maybe accurate. So I'm going to quickly review the genus, origin of the genus Cryptoblepharus. This is the range of Cryptoblepharus from Horner's paper. Marianas are right there. You can see it's got a huge range. This is an artifact that's not real, but it's gone all the way across to Africa. Within the Central Pacific, within poecilopleurus, this study only included 13 specimens, and they were from this area. So they didn't accurately look at the morphology of poecilopleurus in that study. So what we can do is now go and look at the genetics and get a better handle on what's going on. From the work John and I are doing, we tested the origin of Cryptoblepharus. Cryptoblepharus follows an out of Australia hypothesis that its most closely related genera are from Australia, and then it's radiated in Australia and then gone to the Pacific from Australia. Then we did a recent study on the genomics within Cryptoblepharus. There's about 60 plus species in Cryptoblepharus. The Marianas are here. These are some of the sampling units within this larger study. And it's the same kind of DNA approach like John referred to. And what I want you to see here is there's three populations. There's Palau, the Marianas, and then this is Bonin or Osugawasa Islands in Japan. And then we looked at northern Polynesia, Hawaii. We looked at central Polynesia and eastern Polynesia, and then some species that are endemic to western Melanesia, eastern Melanesia, western Polynesia. Real quick, the distribution of the species in, this is of the genus, sorry, let's not call it the species. The genus in the Marianas is that it's the most widespread reptile in the Marianas. From the literature, we've got it from the northern Marianas all the way to the southernmost island, to Cocos Island. And so it's, as far as a lizard goes, it should be like the dominant, it goes everywhere, it's across the whole place. That should be some evidence that it's got very good ability to disperse, and now we can test whether or not that seems natural. So within our recent genomic analysis, what we've done is we've looked at a good series of the species across the genus of Cryptoblepharus. So we saw from John how these trees are made. This is millions of years here, and what we find for the western part of the Pacific Basin, we've got Palau, the Japan Bonin, and then the Marianas. And that's where those three fall on this tree. Red is all Australia and New Guinea. And then yellow is kind of Indonesia. And then some of this are the other Pacific Island clades. And I'll zoom into this in a minute. But basically, the Marianas are an independent invasion into the Pacific, into that region from Japan or from Palau. Palau is a really old lineage that's unrelated to the lizards that are here in the Marianas or in Bonin. Let me just highlight that a little bit more. So what does that mean for Pacific Basin diversity within the genus? So we've got Palau as an endemic species called Rutilis. We've got the Japanese form called Nigropunctatus. We've got this Marianas form that comes out of the tree, unique. And then we've got some other poecilopleurus populations here, and then here that also fall in different places on the tree, and then we've got some endemics down here in New Caledonia, Vanuatu, and Fiji Tonga. So I'm going to zoom into this tree a little bit more. This is now just the tree for the Pacific poecilopleurus type things. And so what does this mean for the diversity within the genus within the Pacific? So what we traditionally called poecilopleurus is actually at least 3 species that are not monophyletic. And in this study, we only included Cocos Island specimens. So this here is where Marianas falls. And then we've got Vanuatu, New Caledonia, these other ones in North and South Polynesia and Fiji. But poecilopleurus, as a name, falls in 3 different places on this tree, indicating that there's probably at least 3 species within that. And then what we haven't done is we haven't looked at the diversity within the Marianas. That remains untested. And 2 minutes left. Okay, perfect. And then there's been described as these unique natural histories within the Marianas that we haven't looked at, and those like on Guguan, where they could represent additional endemic species within the Marianas. And within this whole region, these 3 sites are untested. We didn't include those in our first study, so we don't know what's going on with Wake, with Marcus Island, and then what John recently collected in Rennell. So having shown that the Marianas represent unique historic lineages, we're trying to look at the rest of the distribution within the American Pacific. So these are examples from the Marianas. Recently, they've been reconfirmed on Wake Atoll. In Hawaii, we've spent a bit of time looking around Oahu. We've got Cryptoblepharus on Oahu. Stacy was just out in Howland and Baker in the Central Pacific. And then Kevin's done a lot of work on Johnson Atoll, where they're apparently now extirpated. And so, so we've got an idea. We've now got tissues from a bunch of new areas. We can try to look more at species boundaries within this thing, knowing that in the Marianas kind of stands out on its own. That's not my water, right? I just like, wait. So then I would just quickly talk about risk factors impacting Cryptoblepharus. So we've got cat predation has been described in the literature before. Here, I think musk shrews are probably a big issue. Hawaii, we've got mongoose, brown tree snakes. Here, and then crazy ants, and then centipedes, etc. So there's a lot of things that eat these guys. Question time in a sec. Risk factors, we also have this big issue with invasive species, invasive lizards, both competition and predation. This one here, I can talk about it later, possibly. This is house gecko. We think we have a big competitive interaction with house geckos in Hawaii in some limited habitats. Anoles I want to talk about for a sec. Anoles predate on the skinks and the bone ends. Anoles have been shown to be dominant over the skinks. Guam anoles erupted in the 50s and then crashed as they were a preferred brown tree snake food source. That's in the literature. And then anoles, even though they were highly selected by the brown tree snakes as a food source, they are not that common in the wild. So the tree snakes might have reduced that competition from anoles here, but not in Saipan and other places. Anoles seem to maintain their risk. With regards to Cryptoblepharus typhoon increase intensity and frequency might have an effect. This is Cocos Island. This is my last trip to Guam. This is 91. I was out there with Mike McCoy right after these 2 typhoons, and what Mike found was that even though the numbers of skinks per tree didn't increase, the number of trees decreased, and that he felt there was a big decline in Cryptoblepharus after these back-to-back typhoons. Christmas Island, the species has gone extinct within less than 10 years. I'm almost done. And this study was scary in a lot of ways because it just showed how rapidly species can go from widespread on an island to gone on an island. One thing I wanted to summarize quickly was just the patch size of islands that these things can persist on in Hawaii and also the Marianas and elsewhere, and that we can maybe set up refugia for Cryptoblepharus that are really, really small nickel and dime places, and they can persist for long periods of time. And I'll just conclude with Cryptoblepharus and Marianas represent an old, unique lineage. They're patchily distributed within 17 islands in the Marianas. They're quite sensitive to risk factors and might have extremely rapid population declines. And that we've only, for genomics, looked at Cocos as the only sample, and there might be additional diversification within the Marianas within this species. Thanks. My count was I had more time.
As we get the previous speakers to filter on up here to the panel, we can take a couple questions